Hello, everyone. I'm your host, Nicholas McKay, a first-year graduate student of Technical University Munich's program, Responsibility in Science, Technology, and Society. This is our second episode of STS Shorts, a new video series from Eclectic Spacewalk in which we dialogue with a researcher, lecturer, writer, and/or eclectic human in the science, technology, and society discipline or related fields. These shorts will only be around 30 minutes in length, and the goal is to highlight and hopefully introduce a new audience to our guests' research and work. Please grab a coffee, drink, and open your curious mind as we dive right in. So today we are pleased to be joined by Dr. Shobita Parthasarathy. Shobita is a professor of public policy and the director of the Science, Technology, and Public Policy program at Gerald R. Ford School of Public Policy at the University of Michigan. Shobita is also a co-host of the Received Wisdom podcast. So welcome to STS Shorts, Shobita.
Thank you so much. I'm excited to be here.
Thank you. Okay, so before we get into your research, can you tell us just a little bit of background of kind of how you got to the University of Michigan and then how you became interested in the STS field in the first place?
Yeah, sure. It's a long story, I suppose, but I'll try to keep it snappy since we don't have that much time. So I was, even as a high school student, always kind of toggling between interests in science and interests in law and public policy. I was always someone who was very excited and interested and engaged in politics. And when I went to college, actually, I originally thought, I went to University of Chicago, and I thought that I would do their laws. I think it was called Law, Letter, and Society program. And they actually suspended that program just when I was coming in. And so I, was sort of scrambling around and thinking, okay, well, what do I do? I think I'm pre-law. And University of Chicago has a pretty extensive core curriculum. And so I was taking the classes, science classes for majors, biology classes for majors. And I was like, wait a second, I'm actually interested in this. And so I ended up doing a biology major, but I wasn't really all that interested in the traditional jobs that biology majors do, going into industry or becoming a biologist or becoming a physician. I was still really interested in policy and law. And this was, to date myself, this was around the time that the Human Genome Project was nearing its end. And I was really interested in what it all meant, right? So we're getting all of this information now, or at least I thought, about our genomes. How is that being regulated? What are the implications? And so I, kind of had this idea in my head that I was going to study science and technology policy. Now, that wasn't a thing. Nobody knew what I was talking about. That included my parents, who were like, how about doing something somebody's recognized, at some stage, especially immigrant parents ask questions like that, inconvenient ones. But nevertheless, I went to Washington. I got really lucky, and I spent some time at this as a researcher at the White House Advisory Committee on Human Radiation Experiments. And that was really interesting because it introduced me to the world of bioethics. I mean, I had taken some courses in bioethics, but it introduced me to the world of the history of bioethics, the history of research ethics and institutional review boards. I learned about the politics of risk science, and this commission had been created because there had been some unethical human radiation experiments that had been conducted during the Cold War. And, now they were trying to sort of uncover this history and see whether or not human subjects research had gotten better after there had been, the creation of IRBs and things like that. And so in the process, I learned, as I said, about the politics of risk science, about the nature of bioethics and research ethics. And I didn't exactly know where to go, but what I noticed was that there were consultants to that committee who came from what seemed like on their CVs, right? It said science, technology, and society, or science and technology studies. And so I looked into it, and that sounded interesting. It had words that went together in ways that seemed like they made sense to me. And so I applied. In the interim, then I finished work at the commission. I worked for the National Academy of Sciences. So that was also really interesting. And then I went to graduate school in STS at Cornell. So at Cornell, I did my dissertation was on, which became my first book, was about the development of genetic testing for breast cancer in the US and Britain. And so it kind of started from those early interests in genetics and genomics. And then after I finished my PhD, I had a couple of postdocs, and then I landed at Michigan. In Michigan, was looking for somebody to start a program in science, technology, and public policy in a policy school. And there are it's very rare to have an STS scholar in a policy school, certainly in the United States. But for whatever reason, they hired me, and and I had the opportunity to start this program, which was very exciting to me because, as I suggested, I've kind of always had these interests. And one of the exciting things about the program that I run is that, we already have an STS program in campus, and the STPP program is actually, if just between us, I'm interested in bringing the insights of STS to scientists, engineers, and policymakers. So we have a graduate certificate program where most of the students in that program are from the sciences and engineering, and they get a little bit of STS, and they get a little bit of, the STS side of things that's more about the politics of knowledge and expertise and, comparative governance of science and technology and that side of things.
And so speaking about Cornell, I'm going to bring it up just because it's topical, I guess, but rest in peace, Trevor Pinch. Did you deal with, I
did. He was one of my professors, much beloved professor. I miss him deeply. I use a lot of, his work is just foundational, and continues to be foundational. So Cornell was a very special experience, certainly for me when I was there. It was a small department, and yes, Cornell is, as many of you may know, is kind of in the middle of nowhere. And so I often think that it's a perfect place to do a PhD because you're kind of all together. There's no easy escape.
Not a lot of distractions, maybe.
Not a lot of distractions. There's great collegiality in the department, and so much of that collegiality came from Trevor. He, you have academics who take themselves very seriously and who are kind of difficult and inaccessible, ego-driven. Trevor was none of those things, and it's such an important model to have as a graduate student, to realize that, sure, we're researchers or we're scholars and we're interested in thinking big thoughts, but that doesn't mean we have to be big people, biggest people in the field. One of the biggest people in the field was completely down to earth and fun and caring and warm and lighthearted. And it was wonderful to be able to work with him. And so I will be one of the first people in line missing him.
Well, thank you for that little talk, because that's awesome. I just thought as it came up that
I'd
have to say something about it. Yeah, I'm assuming so. So let's dive into some of your research. So I got from your website, so please correct me and stuff if I go too overboard. But basically, it says your research is focused or broken up into two broad themes. So how can we develop and govern technological innovation to better address ethical, social, equity, and justice concerns? And then the second you're interested in the politics of knowledge and expertise and policymaking, including whether and how scientific knowledge systems shape decisions. So you got in a little bit of that in terms of how you got there, what kind of makes your program different, but let's just kind of dive into that. You do kind of 5 projects, or at least
5 projects,
at least 5 projects. So the COVID-19 politics project, patent politics, inclusive innovation, technology assessment project, and then building genetic medicine. So maybe we start with, as you said at the beginning, with some of the genetic medicine, possibly because that was your. I looked, and it's your most cited paper on Google Scholar: building genetic medicine, breast cancer technology, and the comparative politics of healthcare.
Yeah, so it's not a paper; it's a book.
Oh, okay. Well, then even more better.
I'm kind of interested in on the one hand, the politics of evidence and expertise in policy, and on the other hand, sort of building more socially responsible technology. And really, I would say that what characterizes all of my research is the intersection between them. And so thinking not just about equity and innovation, but how we need to think differently about who's at the table and what knowledge is at the table in order to ensure that more equitable innovation. And now I think I'm in a much better position to articulate that. Certainly as a graduate student, I had no idea. I think that probably the Building Genetic Medicine book was instrumental in that. So basically, as a graduate student, I said that this book was based on my PhD dissertation. As a graduate student, I was interested in genomics and this genomic future. I was also very much interested in activism. As a graduate student, I had read Steve Epstein's book, Impure Science, and really kind of, my mind was blown both by what he was talking about in terms of lay expertise. I also, of course, read Brian Wynn's piece about the famous sheep. So I was excited about this idea of thinking about how, it isn't just scientists who have real expertise in what seem like technical matters. But I was also interested, I should say, in reading Steve's book, in his methods and in how he wrote. I mean, he wrote in such a convincing way. He knew so much, right? I mean, the book is big and thick and rich. And so I sort of wanted to emulate that both in how I write, but also in how I do research. But I also wanted to explore those kinds of themes in my dissertation. And my advisors were Steve Hilgartner and Sheila Jasanoff. And Sheila is well known for her work in science and technology policy and the politics of science and technology. And Steve is well known more in the genomics field, but also sort of sociology of genomics. And he's also very interested in politics and policy. And so, with their counsel, I became interested in this emerging technology at the time, which is genetic testing for breast cancer, which at the time was the first, and still is, of course, the first major disease for which a genetic test was available. And so, it had this potential to really revolutionize the way we think about healthcare and medicine. What does it mean when you find out that you have genetic risk? How are governments going to regulate this kind of information? How are these tests going to be built? And what is going to shape those things? What is going to shape the way that these technologies are built? And so I had for a long time been interested in health policy and fascinated by the British NHS. And so in that, I decided I would do a comparative study, kind of emulating Sheila's style, because she has often used a comparative approach. And so I wanted to find out, how does this technology emerge in these two places that in many respects seem really similar, but are different in these, certainly when it comes to their approaches to healthcare. And what I found was that the technologies were fundamentally different. Actually, there were different technologies. So what happens to your blood in these two places is very different. Wow. And for me, that was, building on the work of Langdon Winner and other scholars who talked about how values are embedded, politics are embedded in technology, and Sheila's work that talks about how politics is embedded in technology policy. What this project showed for me was that national political cultures, national context is embedded in the design of technology itself. And, values, therefore, are also embedded in the design of technology itself. And that has real implications for healthcare professionals, for patients, for societies. And so, that was very interesting also because what is this information telling you? You're getting risk information. It's not, it's not necessarily diagnosing disease. It's telling you you're at higher risk. How is that interpreted in these two places? That was quite different. So it was fascinating. It was a really wonderful experience, and I got lucky. But then as I did that work, I learned about the patentability of human genes. I had not known as a biology undergraduate that you could patent genes, or lots of other life forms for that matter. I learned about it in one of my first year classes in graduate school with Steve. And I remember being bewildered by the idea at the time. Little did I know that it would have a profound impact on not only the story of genetic testing for breast cancer, but in fact on my career. So it turns out that the American company who applied for these gene patents then was able to shut out other providers in the US using the patent rights, and they attempted to do the same in Europe, but a number of European organizations pushed back. And so my book came out in 2007, and I tell some of that story in the book. And my book came out in 2007, and I learned not that long afterwards that the American Civil Liberties Union was planning to challenge this company, Myriad Genetics, patents on the breast cancer genes, as well as the patent office, basically on this question of whether human genes should be patentable. And at the time that I learned this information, I had also decided that my second book was going to focus on the comparative politics of the patent systems in the US and Europe. I was interested in that because of what I had learned in the breast cancer case, and what I thought seemed to be, to me, it was a question: why are the breast cancer patents controversial in the European context? And why do these activist groups seem to have more power in the European context? It turns out that it wasn't quite that simple. In fact, there had been activists in the US. They just kind of been systematically shut down over time. But I happened to be starting that research at that time. And so I actually sent I contacted one of the people at the ACLU who was spearheading this case. And it turns out they already had my book on their desk. And awesome. So then they invited me to a strategy meeting, and I helped them develop this strategy. I was like, listen, I'm not a legal scholar nor a lawyer, so I can't help you with legal strategy, but I can help you with political strategy. And I think that my book, because it kind of meticulously showed the development of the technology and the groups involved and all that was helpful as they were building their lists of plaintiffs, for example. And eventually they also asked me to write what's called an expert declaration in that case, which was then heavily cited in the court. So I had this amazing opportunity for STS work to have an influence on policy. And ultimately in 2013, the US Supreme Court, the case went to the Supreme Court, which is shocking. And then the court unanimously declared that human genes should not be patented. There's a little kind of asterisk on that, but I won't get into that detail now. But I mean, it's incredible to have had that kind of impact, and to be, sort of to be working on an issue that becomes so current and relevant. Sure. And so, as I said, I was at all of this time working on this book about the comparative politics of the patent systems in the US and Europe. And, and there, I think as I said before, my dual interests in thinking about equitable technology and thinking about the politics of expertise really came to the fore. I think it's sort of both of those things are centrally in that book, because what interested me was that, the US and European, in sort of a nutshell, the US and European patent systems think about their roles vis-a-vis the public interest in very different ways. For the US, it is, what I call a techno-legal approach. And in Europe, at the European Patent Office, which is based in Munich, of course, it's a more of a moral and social understanding. And so, in the US, then, aligned with that is, a technical understanding of patents. The public interest is in turn is understood sort of centrally as being the inventor's interest, whereas in the European context, it's seen as a little bit more complex. And all of those things have implications for what gets patented, of course, but also how they understand the relevance even of questions of equity, and morality, so to what extent is a patent office responsible for questions about, for example, the patentability of human beings, right? So that, of course, in the world of biotechnology, those are things we're thinking about right now. We're also thinking about the public health implications of patents on the COVID vaccines, for example. So, the US tends to say, oh, that stuff doesn't belong, that's not part of what the patent system is. And to me, again, trained as an STS scholar with this interest in the politics of knowledge, to me, that's about, how the patent system constructs what I call expertise barriers, which essentially allow them to both say that specific kinds of subjects are germane to the patent system, which also allows them to say, right? So they're saying, here's what it is and here's what ought to be, right? So, we're only focusing on the technical. Well, the technical also presumes something about who gets to be an expert in that space, who gets to participate in that space, and who doesn't. And that, of course, has really, profound implications for democracy, for the public interest, for equity. And so you see how those things are kind of tied deeply to one another. And then, since then, I continue to be centrally interested in this intersection, as I said, kind of looking at how do we make innovation more equitable through the lens of, asking, like, what are the games being played and what is the political economy such that we assume, for example, that the question of equity and innovation policy is one to be answered by technical experts and not, for example, by philosophers or STS scholars, for that matter.
Yeah, and that was how I originally came to you with your recent article in Issues magazine, which was very well thought out and just kind of broke my mind of like science policy in the future, because innovation is one of those Silicon Valley, catch-all words that gets thrown around of anything. And so maybe just kind of go into the thesis of the article, because it was really fascinating to see that as a new frontier almost.
Yeah, well, here's hoping it's a new frontier. So it's interesting, actually, that article kind of, the history is, it's a pandemic history. Maybe 30 years from now, if I'm still around, I'll still look back at that as kind of this catalyst around the pandemic, because the initial ideas for that article came at a symposium in February of 2020, February, wow. I believe 25th and 26th of 2020, which was my last professional trip.
Right in the heart
until I
of
did
everything.
Take a couple. Yeah, I took one professional trip last fall, but like for a long time, it was like the last trip I'd ever taken. To Washington. So the National Academies of Science, Engineering, and Medicine, which is your viewers probably know, is sort of the foremost science advisory body in the United States. It's similar to the Royal Society in the UK. They had a huge symposium to celebrate the 75th anniversary of Vannevar Bush's report, Science, the Endless Frontier. Now, for those of you who don't know, this famous Bush report, as it's known, was basically written by this man, Vannevar Bush, who was a professor at MIT, and then he became the head of the Manhattan Project. President Roosevelt had basically said, hey, science has been like super important in World War II. How should we build our science infrastructure? Right. For the future. And Bush's response was, and many people have written about this. There's wonderful books by Daniel Kleinman, and there's a new book by Mark Solovey about how we should invest in basic science as opposed to applied science. So that's, the Bush report is well known for focusing on basic science. He's also well known for wanting to focus on the natural and physical sciences at the expense of the social sciences, which might make for those of you who know, the NSF program does fund STS research and does fund social research, but to a much smaller degree than certainly as a social scientist, I think it should. But in addition to those things, Bush also was clearly, an uber capitalist and someone who really believed in the free market. And this was actually, he wrote the report at a time when there was kind of emerging concern about the patent system. There was some concern that, maybe it was making technologies less available to people, so it's just embryonic, I would say, equity concerns were emerging. And Bush basically, weighed in on the side of, the government's role is to do this basic science and then facilitate transfer to the marketplace. And so in my remarks to the National Academy Symposium, and I guess I should also add that, many of you may know that report led to the National Science Foundation, but it also really catalyzed a particular approach to science funding in the United States, which is, let's fund basic research and good things happen. What some people know as the linear model was sort of reinforced in the way that the US approaches science policy. And while other countries, especially in Asia, believe in what are called national innovation systems, we are proud that we don't really have a national innovation system. Rather, we fund good research and then we let the private sector take care of the rest, which,
that invisible hand of the market,
Yeah, invisible, right. And so, one of the things that I've noticed in my COVID project is that, we keep comparing ourselves to South Korea, especially in terms when it comes to access to testing or access to masks. But in fact, the relationships are completely different, right? Because South Korea has a national innovation system. So they were immediately able to stand up public-private partnerships in a way that we don't even know where to begin. And certainly we don't, we sort of say we leave this to the market, but then the public sector doesn't know how to reel that back in, right? So there's a huge private sector, but we don't know how to think about that. So in my comments at the academies, I said, we're now at this moment where this was before George Floyd's death and, what gets called a racial reckoning. I said, we are failing when it comes to equity. And, on all of these scores, socioeconomic inequality is higher than ever. When we think about what we want for the future, we want more equity in innovation policy. And I think people heard that, and I gave a short talk, and then they asked me to write this piece for Issues. And in that piece, I basically talk about a number of problems with the current innovation system. So the access problem, which we've already talked a little bit about, the fact that we have a very constrained understanding of what constitutes innovation, right? We tend to focus on commodifiable innovation. In the health arena, it's sort of, molecular interventions, generalizable knowledge, and not, innovation in the built infrastructure or public policy or public health campaigns, for example. We have a constrained understanding of innovators. We think that to innovate, you have to be, have high technical degrees, you have to be part of the market. And we also, as we know, and this is, you can see sort of where STS ideas are sprinkled throughout this, that we also kind of not only distinguish between innovation and healthcare, but we also distinguish between innovation and regulation, such that we end up in funding a lot of what end up funding or otherwise supporting through patents, for example, deeply problematic technologies and then because we have a weak regulatory state, we can't do anything about, or we don't do anything about it until it reaches epic proportions. And if it's, disadvantaging marginalized communities, they're not necessarily going to be the ones who are in a position to be able to say something, right? And so I kind of try to outline that and talk about how, talk about potential solutions. And so I talk about broadening expertise, both in terms of engaging humanists and social scientists, but also vulnerable communities. I talk about, equity assessments, as part of the research process, research evaluation process. And I also talk about, there's an assumption among government agencies, not just in the US, but around the world, that technology transfer is all about the market, that the market is the only engine by which we can ensure that technology achieves public benefit. And I want to challenge us to think differently about it, or at least start to open the space. I feel like communities actually are starting to figure out ways to disseminate important innovation outside of the marketplace, but certainly our large institutions are not fostering that in a serious way. And so that's another way to think about it. So we'll see. I mean, it's exciting that it was published in Issues, because that means that that's going to get read by, hopefully scientists, engineers, and policymakers. They're my target audience. Sure. And so, maybe it'll make a difference. Girl can dream.
Well, we only have a couple more minutes, so I don't want to go over too much of your time. But let's just maybe have a fun little thing of maybe a yes or no question on the last thing you're working on. Do you believe or want basically the resurrection of the Office of Technology Assessment?
Yes. See, that's never a yes or no question. I mean, you're asking an academic, especially an STS scholar. Of course.
I'm being facetious at some level.
I want better technology assessment in government. So right now in the US anyway, the Government Accountability Office has created something that they say is like the Office of Technology Assessment. I would question that a little bit. But I also think the Office of Technology Assessment, it's so important. Again, we as STS scholars, the Office of Technology Assessment was a product of a particular place and a particular time and a particular political context. And it's also really important to remember, so it was around from the 70s to 1994. Yep. And that was an interesting moment in terms of the birth of biotechnology, controversies over nuclear power, but I think that it didn't necessarily reflect a lot of our current concerns about technology. And so their mode of engagement was expert-driven reports on emerging technologies, many of which are brilliant. So those of you who are interested in sort of the histories of emerging technologies, a lot of them are archived online. I highly recommend that. But that fit a particular purpose. And I think we would want more out of it. We know better now, right? At the very least, there's been another 30 plus years of STS, but there's also been all of these allied fields, all of this knowledge, much more engagement. Certainly, for example, if you think about artificial intelligence and, a lot of civil society involvement, we want to think now about an institutional form that fits the 21st century. And I think it would look pretty different, but the idea, which is that when we consider emerging technologies, we need to think about more than just efficiency and safety. Yes, sign me up.
Okay, I'm in with you. So the last week, I mean, we've gone and touched about knowledge, expertise, policy, politics, but then I think one of the things that I guess we haven't touched on a little bit is some of this kind of outreach and communication, which you're actively doing with the Received Wisdom podcast with Dr. Jack Stilgo at University College London, I believe he's at. And so I actually listened to a couple, episodes before this and very impressed. Got some, heavy hitters in there. I mean, Ben Tarnoff with Logic Magazine, some others, et cetera. I'll link to the show notes, but I mean, maybe just give a brief outline of how you're trying to do that, but then also more importantly, move the needle a little bit, not just in the institutional with the Office of Technology Assessment, Issues Magazine. Okay, great, science, engineers, et cetera. But then even not, I don't want to say the layman, but even just normal people that can listen to a podcast and then understand the complexity, but then importance of a lot of these issues.
Yeah, absolutely. I mean, I think, even I remember when I went to grad school, I was sort of initially blown away by the insights that STS had, even, 30 years ago. Okay, I didn't go to grad school 30 years ago, but a couple of years ago.
Right.
And STS has so much to offer. And I think that it is having more of an impact on public discourse than it used to, but there's so much more. I mean, even just the last couple of years, there should have been STS scholars, at the table in these discussions about, whether it's COVID generally and thinking about our cities as socio-technical systems, thinking about vaccines and vaccine hesitancy in different ways, in more nuanced ways, that we offer insights that are crucial to understanding this modern technological society, right? Where we should be everywhere. And I want to do my part to help us get there. And so, I do that by writing for the public, sort of seeding these ideas, whether they're obvious to people or not, writing a lot of policy briefs, teaching my policy students and my science and engineering students, little, more applied chunks maybe, but, I'm also trying to do the more heavy hitting scholarly work, but this is so important to me. And the received wisdom is a part of that. So Jack and I, basically the way that we've structured these episodes is Jack and I spend the first half kind of doing, let's run the news of the day through an STS grinder, basically.
It's a good way to describe it.
That's what I like to think of it as. And then we spend the second half interviewing somebody who is doing work on STS issues that are really of great public or policy importance. So, on vaccine hesitancy, we had Maya Goldenberg on, when Ruha Benjamin put out her book on race and technology, we had her on the podcast. The most recent episode has Kyle White talking about indigenous knowledge and climate change. And so, we want to spotlight those people who are doing this kind of work and what they're thinking, but also as you said, for the layperson, but also showing to STS scholars how they can do translational work too. So a lot of the people that we interview are trying to do that translational work. So sometimes we talk about the challenges. We had Jason Delborn on talking about gene drives, for example, and he's been on a lot of National Academies committees and he's had some impact. So, how do you do that? How do you convince a bunch of scientists to kind of put the STS into these important policy documents? So
pressure from all around. That's where it's coming from.
Right,
pressure from all around.
Exactly. So
I like that translational work because that's basically where, as a podcaster and filmmaker and et cetera, like that's kind of more where I'm coming from as a former journalist. So, I thank you for this is all the time we have. So we could do this forever. And Jack, you're up next. So by the way,
that sounds great. I can't wait
to do this.
He better not say anything bad about me.
Of course not. I won't let him.
No.
But thank you so much for your research. Thank you for everything. And we'll definitely be in touch. I hope the audience, enjoys your work and research and finds it, useful. So
me too.
Thanks for coming on STS Shorts, Shobita.